So okay, in the last class we are discussing about the keyboard interface to 8086. So in that we have discussed about the first two steps, which is detect, debounce. The third one is decode. So here we know that the rows are connected to PA0, PA1, PA2, PA3, and columns are connected to PB0 to PB7. So in that the same row information is taken at PB0 to PB3, and the column information is taken at PB4 to PB7. Okay. So the codes corresponding to key press 0 is, so when a 0 key is pressed, in order to detect that key 0 key, so when 0 key is pressed, PA0 to PA3 will contain 1110, but this is connected to here. So PA0 is PB0, PB0 is 1 only. So for 0 press, this key will be 1110, because this 0 key is present in this row and column. What is the hexadecimal equivalent of this one? So if I receive this 0 1 1 here, means there is a 0 key press. So the code will be E7. Corresponding to 1, this will be EB. Okay. So corresponding to 2, so 2 is here, so this should be 1110 only for 2 also, and 2 is here, means this should be 0. 2 is in PB6, PB6 should be 0. So 1 1 0 1, so this will be D, 13 is D, ED. So corresponding to 4, this will be same 1110. Corresponding to all these 4 keys, this code is 1110 only this will changes. Here this 0 will be shifted. So here 0 was here initially, now here, now here, now this will be the last one, shifted towards the right by 1 bit position. 1110, P7 is, this 3 is connected in P7 line. Okay. So this will be E. Similarly, you can obtain the codes for 4, 5, 6, 7 and so on. So what I am going to do is, here I am going to store these values in some location. So I want to store some location, say 6000 H in data segment. The starting of this data segment is 50,000 H. $60,001, 6,002. So instead of this I will take this 0 0 and 0 1, these last 8 bits I will take as the code corresponding to 0 1 2 and so on. So the codes are E7, EB, ED, EE. E7, EB, ED, EE. Here I will simply store 0. This is code corresponding to 0. So I will store 0 0 0 1 0 2 0 3, because these are the codes corresponding to, these are the code corresponding to 0, this is the code corresponding to 1, this is the code corresponding to 2, this is the code corresponding to 3. So I will store this data here. Finally I want to read this data into accumulator AL. Similarly 0 4 6 0, the code corresponding to 4, the code corresponding to 4 will be, so for 4 this sequence will be, this PB2 should be 0, remaining all should be 1s. For 3, this is 3 for 4, so 4 is here, so this bit should be 0, remaining all will be 1s. So this bit is connected to PB2. PB2 means this is 0 0 1 0 0 1, and correspondingly 4 is there in this row, so means PB4 should be 0, PB4 should be 0, remaining all will be 1s. This will be now, this is D7, so I have to store D7 here, the location D7 I am going to store 4. Similarly 6 0, this will be code correspond to 5. We can obtain this in a similar manner. This will be code correspond to 6. So on up to this will be code corresponding to F, 0F. Totally we have 16 locations. Okay. To read this value into AL, so at the end of this program, this AL will contain the code corresponding to these 4 rows and 4 columns. This entire code, this code will be contained in AL at the end of this program. Now to read that value into AL, okay. So what I will do is move AH comma 0 0 6 0, because I want to store this in a locations of 6 0. This value is there in AL, AH I am initiating to this one, so that AX will be having this address, that I will take into some register. Move BX comma or SI comma AX, then move AL comma contents of SI, because in that particular location we have the code correspond to the key that is pressed. So that I am going to take into accumulator, then halt. So this process is to decode the program, decode the key. This is how we can interface the keyboard to the 8086 microprocessor. Now the next device that I am going to discuss, which is an important output device, which is output display, interfacing of output display to 8086. There are several types of the output displays. The simple output display is 7 segment display. As the name implies, there are 7 segments. This is segment A, B, C, D, E, F, G. So we can display all the digits from 0 to 9. Okay. Then suppose if we want to display in addition to the digits the alphabets also, then we have to use alphanumeric displays. Alphanumeric display, we have 18 segment displays, such as this is the example of alphanumeric display. Using this you can display any alphabets also. There is another type of display which is called matrix display. If we take say 5 by 7 matrix display, here will be having IC. The segments are arranged in a form of a matrix. So we will be having 5 by 7 means 5 in a row, and 7 such rows. By appropriately selecting the segments, you can display any alphabets on this display. So, totally we have 35 segments, 7 rows, 1, 2, 3, 4, 5, 6, 7 and 5 columns, and there will be one extra segment here to represent the dot. If I take inside this, the circuitry will be something like, so we have 6 rows totally, connected through diodes, that is light emitting diodes, LED. This will be connected to a port, and then we have here along these 7 rows at each intersection we have another segment. Here at this we have diode. So, this is correspond to this particular segment. This can be on or off by properly selecting these rows and columns of this particular LED. Similarly, here we have LED. So, there are total 35 LEDs here. So, like that, by properly selecting these rows and columns, we can select any of these segments, thereby we can display any digit or any alphanumeric letter. Okay. This is about the 7 segment display. Another is CRT display, cathode ray tube display. The first 3, these 3 are used for to display the small amount of the data. To display small amount of the data, we can use either 7 segment display or alphanumeric display or 5/7 matrix display. Whereas this last one, CRT display, most of the computers uses CRT display, whereas the microprocessor kits or some instruments uses this LED displays. So, this mean a CRT kit to display large amount of the data. First, we will discuss how to interface a 7 segment display to the microprocessor 8086. Interfacing of 7 segment display to 8086. There are 2 types of 7 segment displays. One is called common anode, another is called common cathode. As I have discussed, there are totally 7 segments. Correspond to each segment, as in the case of a data matrix, we have a LED inside that, A, B, C, D, E, F. Okay. So, correspond to A, we have one LED. correspond to B, correspond to C, correspond to D, correspond to E, correspond to F, correspond to G. So, each one will be having one anode and one cathode. So, if it is common anode type, as the name implies, anode should be common to all the 7 LEDs, and this will be connected to a common point. This is called common, and each segment is connected to one particular pin. This is A, this is B, this is C, this is D, this is E, this is F, this is G. Now, to glow any LED, if I want to glow this, anode is connected to common, which common has to be connected to plus 5 volts. To glow a LED, this anode should be plus 5 volts, this should be, we have to ground or 0 volts. Okay. So, if A is equal to 0, implies the segment A will be lit. Means on. Okay. Similarly, if B is equal to 0, segment B will lit, C is equal to 0, C will lit. Okay, depends upon the segment that is required, we have to lit the corresponding segments. This is common anode type. In common cathode type, reverse. The common point is connected to all the cathodes. In case of common cathode type, all the cathodes will be connected together. So, all these cathodes will be connected to common point, which has to be grounded. Then anodes, you have to connect, to glow a particular segment, you have to connect logic 1 or plus 5 volts. This is common point, which has to be connected to plus 5 volts or logic 1. And to display any particular segment, this has to be connected to logic 0, so that this A will glows. This is B, C, D, E, F, G. This is about this common anode type and common cathode type. So, inside this 7 segment display, we have this circuitry. Depends upon whether the display is common anode type or common cathode type. Okay. Now, one way to interface this 7 segment display to 8086 is, so I will simply connect to one of the ports of 8255. So, I will take one port which will be having 8 bits. This is 8255. So, I am not showing the connection with 8086 that we have already discussed. So, I will take one complete port of this one, say port A with the address of FCH, and controller register is having address of FFH. This is PA0, this is PA1, PA2, PA3, PA4, PA5, PA6, PA7. This is PA0 to PA7. This I will connect to 7 segment display. Of course, we require some current limiting resistors here, because the current capacity of this segment is around some 20 milliamps, whereas the microprocessor current is more. So, we have to use the current limiting resistors of the order of 150 ohms. each. This is a 7 segment display. So we can find that for 7 segment display we have 7 segments A, B, C, D, E, F, G. There will be one pin corresponding to common. So it depends upon whether this display is common anode type or common cathode type. This common has to be connected to either ground or plus 5 volts. Here let us assume that this is common anode type, common anode type. Okay. So this common point has to be connected to plus 5 volts, and if I send a logic 0 on any particular segment, that segment will close. This is A, B, C, D, E, F, G. Okay. This is interfacing. So if I want to implement a decimal counter on this particular 7 segment display, to implement a decimal counter, means first you display 0, then 1, then 2, so on up to you go up to 9, then after 9 again you come back to 0 continuously, and you allow time between 2 consecutive counts as some time, say it can be 1 millisecond, 1 microsecond, that is depends upon the application. So I want to program this as a decimal counter which counts from 0 to 9 repeatedly, which is also called as a decade counter, or this is because it counts from 0 to 9, this is also called as decade counter. Then the first step is how to display digits. 0, I want to display 0 like this. I have only one option only. So in order to display 0, so these are the segments that has to be glown. A, B, C, D, E, F. G has to be off. To display 1, we can select 2 ways. One is we can use only BC to display, or you can use FE also. If I select FE also, this displays 1. So I want to display 2 like this. So what are the segments? A, B, D, E, G. 3 I want to display like this. 4, 5, 6. This depends upon your design. This can be excluded also. Without this also it will seems to be 6 only. 7 is this. 8 is all the segments. 9 also here. This is also 9, or you can include this also. Okay. Depends upon your requirement. So I want to display the digits 0 to 9 like this. Okay. Now what are the codes corresponding to this? I will store in a lookup table. Okay. So if I want to display 0, what is the code that is required? What should be the PA0 to PA7, PA7, PA6, PA5, PA4, PA3, PA2, PA1, PA0. Okay. Decimal digit, and then I will find out the corresponding code. So decimal digit is 0, say. Okay. So in order to display 0, this is common anode type. This is PA0 is connected to A, this is connected to B, this is connected to C, D, E, F, G, and this is connected to common point. So in order to display any digit, this should be always 1. Common has to be connected to, anode has to be connected to 1. And to glow any segment, I have to send a logic 0 on that particular segment. So for 0 except G, so I have to glow all the remaining segments. So G must be 1, all will be zeros. So 0 means segment will be selected because this is common anode type. So what is the hexadecimal code corresponding to 0? Is 1100 is 12, this is 0. 12 is nothing but C, 0H. In hexadecimal, C0H. Okay. Similarly, you obtain from 1 2 so on up to 9. 1, this will be always 1 because this is common anode type. So, display 1, only I want to glow B and C, remaining all has to be 1. So, this is 1 1 1 except B and C, this is B and C. So, both should be, this is sorry B and C, this is 1, this is D, B and C should be 0, this will be 1. What is the code? F9H. Corresponding to 2, I want to glow A, B, D, E, G, A, B, D, E, G. Okay. So, what is the code? This will be 1. I have to display G also 0, F is not there, so 1, E is there, so 0, D is also there 0, C is not there 1, B is there 0, A is there 0. So, what will be the code? 1 0 1 0 is A 10, 0 1 0 0 is 4, A 4H. Similarly, correspond to 3, what is the code? This will be 1 always. 3 means I want only this A, B, C, D, G, A, B, C, D, G. So, A, B, C, D, G should be 0, F is 1, E is also 1, A, B, C, D, remaining 4 are zeros. This will be B 0H. Correspond to 4. So, I want this 4. So, what are the segments? Segments are B, C, F and G, B, C, F and G. This will be 1, B, C, F and G should be 0. F and G, B and C should be 0, remaining all are 1s. So, what will be code? 9, 9H. Correspond to 5, this will be 1. 5 means it will be except F and E, F and E will be 1s, F and E will be 1s, remaining all will be zeros. So, this will be B 0H, this is B 0H, 1 0 1 1, 0 0 0, 5 is B 0H. 5 will be 1 2 3 except B and E, B and E, B and E. So, B should be 1. So, this will be 9 2H, because these should be all distinct. Similarly, 7 6 7 8 9. So, this will be always 1 only. 6 is except B, remaining all has to be zeros. So, this will be 8 2H. 7 is only ABC, has to be 1, remaining all are 1s. Only ABC is 0. ABC should be, this is also D 1, ABC should be 0 0 0. So, what will be value? F 8H. 8 is all must be 0 except the common pin. This is nothing but 80H. 9 is all except E. This is 0, this is 0, E should be 1, remaining all will be zeros. This will be 9 0H. So, these are the code corresponding to this. So, I am going to store these values into some memory location starting with some offset, say some 6000 offset in a data segment. Whose starting address is say 50,000. So, this will be 56,000, offset is 6,000, then 56,001, 56,002, 56,003, 56,004, 56,005, 56,006, 56,007, 56,008 and 56,009. So, here I am going to store C0, F9, A4, this will be B0, 99, 92, 82, F8, 80 and then 90. The addresses we are not using. Okay. Now, I want to display these values through this. First you display this C0 value, then you display F9 value, you display A4 value and so on. Okay. And in between you call a delay subroutine of 1 milliseconds. So, what will be the program now? The program will be move AX comma initialize the data segment 5000H, move DX comma DS comma AX. Okay. And initially you have to use this port A as output port, because we are going to send the data from 8255 to output device, and the remaining ports we are not using, and we have already generated in the earlier classes to program all the ports in mode 0 as output ports. 80H is the control load register. You have to load 80H inside this one, then this will program all the ports as output ports in mode 0. Okay. So, further the instructions are move AL comma 80H out, control load register address is FFH comma AL. So, these two instructions will program all the ports as output ports in mode 0. Okay. A 0, I have to display 0 on here. So, what is the code corresponding to 0 is C0, which is there in the location of 56,000H. Okay. So, for that I am taking same logic I am going to use that I have used it in the keyboard interface for decoding. Move AH comma 60, because this offset is 6000. So, in that 60 I am taking AH, move AL comma 00, so that AX points to 6000. So, in the location with 6000 offset we have the code corresponding to C0, which is code corresponding to 0. So, we take move SI comma AX. Okay. So, we are taking this SI with 60,000H where 0 code is available. Okay. Then move AL comma contents of SI. So, after this instruction AL will contain C0H, which is the code corresponding to 0, C0H. So, if I output here C0H from here, a 0 will be displayed on the 7 segment display. So, for that what is the instruction? AL is having this one out, the port A address is FCH, the contents of AL which is C0H, so that after this instruction a 0 will be displayed on the 7 segment display. Then you call a delay. You can set any value of the delay, depends upon your application. Okay. you can set 1 millisecond, 2 milliseconds. We know how to write the delay program. Then after that we have to display logic 1. Okay. So to display logic 1, digit 1 whose code is present in 56001H. So you have to just simply increment AL, INCAL, compare AL with 09. So up to 09 we have to increment this. We will compare with otherwise A, because 9 also you have to display, right. So you take one above this 0A, jump not equal, up. Okay. For 0, 0, 0A if you compare, it will be not equal, 0, 1 with 0A not equal. So after 9 also we are going to compare with A, not equal, this will be, this particular instruction will be false, it will come out of the loop. Okay. So if it is not equal, you have to go to the up, true. If this is 0A, after displaying all the digits 0 to 9, then 0A with 0A they are equal, so this is false, this will come out of the loop. So from 0 to 9 this will go to the up. Where should be this up now? This up should be here. In AH permanently 60 is there, in AL we have this 0A, so that is to be taken into this contents of SI. So SI will be pointed to this 0601. So after this instruction AL minus 0A is performed, but the result is discarded. AL contents are here after the first iteration 01, that 01 remains in AL. So when this is not true, here it will go. So in this AH will be having 60 only. Now in the second iteration AL will be having 01. So the offset of 6001 means, which is correspond to a code correspond to digit 1 is stored in that particular location. Okay, is it clear now? Now it will display here 0, 1, 2 with a delay of, the delay that is going to be decided by the application. So it will go up to 9. After 9 what happens? This will come out of the loop, but I want to repeat the process. So you write unconditional jump to up 2 or unconditional jump to repeat, you can call. Where should be this repeat? This repeat should be again this. So that again AL will be taken with 0, 0. So the code corresponding to 0 will be displayed. So like that this loop will continues. This is how we can interface a 7 segment display to the microprocessor 8086, and then we can program this 7 segment display as you wish. So here I have explained this program to display a mod 10 counter using 8086. Okay. This is one way to interface the common cathode display. Directly you can connect this port to the this 7 segments directly. If I want to connect multiple 7 segment displays, in some applications we need multiple 7 segment displays. If it is a single 7 segment display, I can do in the manner that I have explained now. Okay. So in order to connect multiple 7 segment displays, normally we will use a BCD to 7 segment decoder, which is called 7447. There is a IC 7447. So which will be having 4 BCD inputs, and 7 segment output. and the output of this 7 segment display we are going to connect to through this current limiting resistor to display 7 segment display. There are some additional pins for this 7477 that I am not explained. These are the important pins. So, I will connect to this corresponding display A to G. This is A to A, B to B, C to C, D to D, E to E, F to F, G to G. Now, this requires only 4 BCD inputs. Okay. So, this BCD I am going to give through the 8255. Instead of using a complete port here, now we can use only 4 pins of any port. If this is PA 3, PA 2, or you can use the higher order port, it is up to you, PA 7, PA 6, PA 5, PA 4. Only 4 pins of a port A. The remaining 4 pins I am not using. This is port A. I am assuming the same addresses. FCH is the address of the port A, FFH is the address of the control load register. Now, you have to send this BCD code. If I send 0000, then what is the code required for this if it is a common anode type only? If I call this inputs as ABCD. ABCD. This ABCD is going to be sent by 8255. This ABCD to common anode type as you have discussed in the previous slide, to display 0, what is the code? C0H. Okay. So, of course, this common point has to be connected to this C0H, in that this is 11 0 0 0 0 0 0. This is of course common point, but we are not considering here. So, A to A B C is in this manner, A B C D E F G. So, this 1 0 0 0, this will be generated here. This will be 0 0 0 0 0 0 1. So, if I display 0 0 0 0 here, output here, then corresponding 0 0 0 0 0 0 1 will be displayed, thereby here it will display 0. Okay. Similarly, if I use 0 0 0 1 here, a code corresponding to 1 display will be appeared here. So, this job will be performed by this BCD to 7 segment decoder. So, the job of the BCD to 7 segment decoder is, as the name implies, you give the input as BCD, output is 7 segment display code. Okay. Depends upon whether BCD is 0, 0 code will be generated, 1 code will be generated, and so on. Okay. Now, how to write the program? Again, to implement the same decimal counter or mod 10 counter. Here basically you have to give only 4 bit BCD. Okay. So, you assume the same locations, move AX comma 5000, move DX comma AX, then these connections are, we are assuming only we have to give output the BCD. Okay. Move, here also you have to output in program all as output ports in mode 0. So, out FFH comma AL. So, these two instructions will program all the ports as output ports in mode 0. Okay. Now, we have to display 0 0 0 0 on 7447, then 0 1 0 2 and so on. Okay. So, I am taking move AL comma 0 0 H out, this is port A address is FCH, FCH comma AL. With these two instructions, for what happens, this 0 0 H means 0 0 0 0 0 0 0 0. These 4 0 0 last zeros are this first 4 PA7 to PA4. These are connected to, this is connected to ABCD. Okay. So ABCD is 0 0 0 0 means, so 0 will be displayed. So with these two instructions, a 0 will be displayed on 7 segment display. Then you call a delay of any time that is required by the application. Then I have to increment this. So I have to increment this 0 to 0 1. Okay. So for that you set the carry. This will be more convenient if I use the lower order 4 bits instead of the higher order 4 bits. Let us assume that this is PB3, 2, 1 and 0. Okay. So this will be last 4 bits, ABCD will be last 4 bits. For the previous one also we can write the program, but it will be somewhat complicated. This I am connecting to PA0, this to PA1, this to PA2, this to PA3. Okay. So after that I will write INC AL. It will be 0. I will compare with AL comma 0 AH, because I want to display up to 9. So I am comparing with the 10. So whenever this AL becomes 10, so this these two will be equal, it will come out of the loop, at 10 will not be displayed, it will display up to only 9 only. I let the same instruction jump not equal up. So this up is because you have incremented only outputting, this is the up. So this will display 1 now, then in the next loop it will display 2, next 3, next 4, next 5 up to 9. After 9 AL becomes 0A, and we are comparing this 0A with 0A. So this will be equal, this will be false, this will come out of the loop. So you have to write unconditional jump to repeat. So where should be this repeat? Again you have to take AL with 0 0 0. So this will continuously display 0 to 9 on this particular 7 segment display. So this program is relatively simpler because we are using BC to 7 segment decoder. Okay. If I want to connect a multiple 7 segment displays, suppose if I want to connect 8 7 segment displays, then we have to use 8 7 4 4 7s. Okay, if I want to directly use. Okay. So for interfacing, eight 7 segment displays. We have to use 87447 ICs, and when a particular segment is on, it draws a current of 20 milliamps. Okay. And if I want to display 8 on each segment, on each display, so if I have single display, to display 8, this will draw 20 milliamps, this will draw 20 milliamps, so total this will be 140 milliamps. If I use 8 such displays, what is the total current? This is 140, this is 140 milliamps and so on. So total will be 140 into 8 milliamps. This will be of the order of 1120 milliamps or 1.12 amps. This is a large current, so this will draw more power. This is one of the drawback of using this type of configuration for displaying multiple 7 segment displays, This is one drawback, is it draws more current, thereby more power consumption. In addition, we have to use 7 7447s. Okay, instead of using this 7 7447s, we can use a technique called multiplexing technique. multiplexing technique. If you use the multiplexing technique, using one single 7447 itself, we can display 8 7 BC to 7 segment displays or 8 7 segment displays. Okay. So, how to connect 8 7 segment display using only single 7447 in a multiplexing mode, that we will discuss in the next class. Okay. Thank you.